Hello, today I'm going to do a numerical example over chemical reaction rates and verify some of the relations we got last time. So recall that a chemical reaction rate was the change in concentration over the change in time over which that concentration change occurred. So, for example, for oxygen, in this time interval between 300 and 400 seconds, the concentration increased. So that corresponds to a formation rate, and the dinitrogen pentoxide decreased in concentration. So that was a decomposition rate. The slope of this line, the average slope, is going to be negative between 300 and 400 seconds. And likewise for nitrogen dioxide, between 300 and 400 seconds, the concentration is going to be increasing, so that corresponds to a formation rate. And then from the stoichiometric equations, we had two dinitrogen pentoxide molecules decomposing while only one oxygen was being formed. So we needed to divide the rate of decomposition of the N2O5 by 2 to compensate. And then likewise, since there were 4 NO2 molecules forming and only one oxygen, we had to divide the rate of formation of NO2 by 4. So I've got some data from an actual experiment. So what I'm going to do is calculate the slopes of these lines from that data and show how these relationships between the rates for each molecule is verified. So let me clear the screen here and calculate the slope of the oxygen between 300 and 400 seconds. And it was experimentally determined that at 400 seconds the concentration of the oxygen gas was 0.0049 molar, and at 300 seconds it was 0.0040 molar, and this works out to be 9 times 10 to the minus 6 moles per liter per second. And for the NO2, we have, during the same time interval, the concentration at 400 seconds was 0.0197 molar, and at 300 seconds it was 0.0160 molar, and this works out to be 3.7 times 10 to the minus 5 moles per liter per second. And finally, for the N2O5, between 300 and 400 seconds again, we have 0.0101 molar at 400 seconds, and at 300 seconds we had 0.012. So notice here that the concentration is diminished at 400 seconds over what it was at 300 seconds. So this is going to work out to be a negative 1.9 times 10 to the minus 5 moles per liter per second. And then on the basis of the stoichiometric equation, we determine the relation between the rates of the different components here. So for the O2, it was negative 1/2 the rate of decomposition of the N2O5. And plugging in these numbers, see the rate of decomposition is negative 1.9 times 10 to the minus 5. And this is moles per liter per second, and that works out to be the same as we had up here, approximately. There's some experimental error in here. And then finally for oxygen, it was only 1/4 the formation rate of the NO2. And the NO2 had 3.7 times 10 to the minus 5th moles per liter per second. So that works out again to be approximately equal to 9 times 10 to the minus 6 moles per liter per second. So those relations are verified experimentally. So that's all for today. Have a nice day.